Hello folks, this is video 3 of 5 for Unit 7, an introduction into bonding. In video 2, we talked about how atoms interact with each other and how they share electrons in order to obtain a noble gas configuration, which means for most atoms, this is 8 electrons around it. In an example, H2O, or water, we see that each hydrogen atom has got 1 valence electron, and the oxygen has got 6 valence electrons. Since these are interactions between nonmetals, we will form covalent bonds, and the result will be a covalent compound. As you can see, the electrons between the hydrogen and the oxygen are being shared, resulting in these covalent bonds shown by the solid lines. And in this picture on the right, please don't be concerned about why water has this particular shape or why these electron pairs around the oxygen are not being involved in bonding. This will be discussed in more detail in Units 8 and 9. If we count the electrons around each of these atoms, we see that each hydrogen has got 2 electrons and the oxygen has got 8 electrons. So in the case of the oxygen, its 2s shell is now full, as is its 2p shell. So it looks like a noble gas and has the 8 electrons around it. We call this the octet rule. In a more complicated example, we can look at CS2 or carbon disulfide. We can use the Lewis dot diagrams to draw a structure with multiple bonds present. In the example of carbon disulfide, we see that the carbon atom has got 4 valence electrons, and each sulfur atom has got 6 valence electrons around it. In the case of the carbon, all 4 of its valence electrons are unpaired, and for each sulfur atom, 2 of its valence electrons are unpaired. Therefore, for each of these atoms to attain their octets, we're going to have to make multiple bonds. As we can see in this Lewis picture, we've got a sharing of the electrons to make the multiple bonds. We've got 2 sets of electrons between the carbon and each sulfur atom. Each pair of electrons will represent 1 bond, so the 2 pairs of electrons will represent double bonds between the carbon and each of the sulfur atoms. In question number 1 in the notes, it asks to draw the Lewis structure for nitrogen gas N2. And we can see here that each nitrogen atom has got 5 valence electrons, and 3 of those are unpaired. Therefore, for each nitrogen atom to fill its octet, each nitrogen atom is going to have to share 3 of its unpaired electrons with the other nitrogen atom, shown here in the Lewis structure. Each of these 3 sets of paired electrons represents a single bond. So in N2, there is a triple bond between the 2 nitrogen atoms. Now, the reason why nitrogen has got 5 valence electrons is because of its ground state electron configuration. Its condensed version is helium, 2s2, 2p3. The 2 electrons in the s orbital and the 3 electrons in the p orbital are those 5 valence electrons shown here in this example. In videos 4 and 5 for Unit 7, we will be discussing the electronegativity of atoms, how their differences can be used to determine whether or not a bond is polar, and how the polarity of a bond can affect the physical properties of a compound, such as its boiling point or its melting point. This concludes video 3 of 5 for Unit 7, an introduction to bonding.